Hello everyone, in this video I'm going to show you how to graph an exponential function using transformations. So let's just jump right into it. The first step you want to take when graphing any function using transformations is to identify the base function, also known as the parent function or starting function. So yeah, whatever function that you're going to be starting with. And the way you identify that function is to identify your base and then write it to the x power. So I'm going to call it g of x, and I already wrote it. G of x equals 3 to the x. And then you want to identify some key points to go with that function as step 2. So write a little chart here, and we can choose let's see, -1, 0, and 1. And then, of course, we have a horizontal asymptote, y equals 0. Okay, so we're going to evaluate g at all these points, at all these x values. So g of -1 is 3 to the -1, which is a third. G of 0 is 3 to the 0, which is 1. And g of 1, which is 3 to the first power, is 3. And these are the points that your textbook chooses. They're just small. These x values are small, easy numbers to work with, to evaluate the function at. Okay, so I'm going to rewrite f of x. So f of x equals 1/2 times 3 to the x plus 1 minus 2. And what I'm going to do, actually, before I start, I'm going to rewrite this here. I'm going to factor out the negative sign. So this is what I'm going to use right here, this piece. Okay, so I'm going to write a chart that will go with it. And then right here, as our step 3, is what the arithmetic that you're going to be using that will help you do your transformation. So this is important. This is really important right here. This is the arithmetic that's going to help us do our transformation. So let's look at from the starting function to our function here that we have, and just look at the differences in the x. So from this x to this x, what happened? So with the x's, you always do the opposite operations to the x's. So, and I'll show you why in a minute. So here, again, I had this, I went ahead, whenever I have something in front of the x, I factor it out. And so now this is what I'm working with. So the arithmetic that's being done is I'm going to divide by -1 and then add 1. So divide by -1 and then add 1. So remember I said that the arithmetic that you do to the x is the opposite of what's being stated. And we'll discuss why that is in a minute. You don't need to know why that is, but I can show you why. You just remember that you do the opposite. Then we look at the y. So g of x is function notation for y. So y is 3 to the x. So from here to here, we multiply by 1/2 and subtracted 2. And so with the y arithmetic, you just write it as is. So we multiply by 1/2 and subtracted 2. Now, all this arithmetic we're going to do to these x and y values here, including the asymptote, to get our new points. Okay, so to the x's, I'm going to divide by -1, then add 1. So -1 divided by -1 is 1. 1 plus 1 is 2. 0 divided by -1 is 0, plus 1 is 1. 1 divided by -1 is -1, plus 1 is 2. I'm sorry. 1 divided by -1 is -1 plus 1 is 0. Okay, now to all the y values, we're going to multiply them by 1/2 and subtract 2. So 1/3 times 1/2 is a 6, and then we're going to subtract 2, and we can look at that really quick to find the approximate value. So 1, 6 minus 2. So it's about negative 1.83. So about negative 1.8. And I'll just do all the arithmetic on the calculator for y'all. Okay. So 1 times a half is a half minus 2. And that's actually that's easy to do. That's negative 1.5. But show you. So we have 1/2 equals, and then we subtract 2. Negative 1. And then 3 times a half is 3 halves minus 2. And again, we have another easy one, negative 0.5. So 1/2 to 1/2 minus 2. So negative 0.5. And then to this one, this is also y value or horizontal. So we do this arithmetic to a y value as well, to a horizontal as well. So 0 times a half is 0 minus 2. Our new horizontal is our y equals negative 2. Okay, so before we put this down, let's go ahead and go back and look at our starting function. So I like to write my asymptote first, y equals 0. So that's denoted by a dashed line. And then negative 1, 1/3. So like right here, 0, 1, 1, 2, 3. And this is the shape it takes. And of course, the graph just gets closer and closer to the asymptote, but it never crosses or touches. We're just approaching it. Okay, so we're going to take this and we're going to, our x's are going to be negative. So there's going to be, the graph is we're going to flip it this way, right? It's going to be a reflection about the y-axis. Okay, so it's going to be like, flip like that. And it's going to shift right 1 unit, right? Because remember, we always do the opposite. So it's going to go right 1 unit. And what else is going to happen is that there's going to be a vertical compression by a factor of a half. And we're going to shift the graph up. I'm sorry, shift the graph down 2 units. Okay, so, and you'll see it here after we plot all of this. So y equals negative 2 is here. And then 2, negative 1.83. So 2, so just like here, 1, negative 1.5. So it's here. And then 0, negative 0.5. And then this shape, and it just gets closer. It gets closer and closer, but it's not supposed to touch or cross, but so it's kind of like that. It gets closer and closer. And that's it. This is the answer right here. This is the graph of this function using transformations. So as you can see, the graph flipped about the y. And it shifted right 1. You can see that. And it shifted down 2 units. You can definitely see that very clearly from the y equals 0 asymptote and now to y equals negative 2. And there is a vertical compression. And that's it. So what we can do is really quickly find the domain and range of this function. So the domain of a, and we can also find the domain and range of the original too. The domain of an exponential function is always from negative infinity to infinity. The range, all you have to do is look at the graph and we start at the lowest, we read bottom to top. So the lowest part of the graph is here at -2, but we don't include it, so we don't put parentheses that denotes that it's not included, right? Because that's an asymptote. And then the graph just goes up. So it just keeps going. And then, so for this, oops, it's range. The domain is negative infinity to infinity for an exponential. And the range, the lowest to the high, reading lowest to highest, is 0, not including, right? Because that's an asymptote. And then it just goes up. And that's it. That is how you graph an exponential function using transformations, and really any function using transformations. You first identify the starting function, identify some key points, just choose easy small numbers, any key features like asymptotes. And then this is the important part here. This is actually where the arithmetic that's going to do your transformation. So how do you fill this in? Well, first we look at how x is changed from here to here. And if there is a number in front of x, we factor that first. And so x's are, we do the opposite. So we divide by -1 and add 1. And then with the y, so from here to here, we multiply by 1/2 and subtract 2. So just as you see it for the y values, whatever arithmetic there is, do that. And then you do all this arithmetic on these problems, and you get, these points, and you get these points, and this is what you want to put on what you want to graph here, and this is your answer here. And then I just found the domain and range of a function, and then you can see the transformations. So real quickly, again, you don't need to know why, but so why is it that the arithmetic is opposite on the x but the same as you see it on the y? And the way I think of it is, I guess I'll just kind of write it here as some like little side scratch work. Again, this isn't something you absolutely need to know in order to do these problems. But so I'm going to write this. So when we evaluated this function due to the x at these numbers, it was easy. 3 to the -1, very easy. 3 to the 0, 3 to the first. Easy to evaluate. So we want the same thing here. We want this to be -1, 0, 1, so that we can have 3 to the -1, 3 to the 0, 3 to the first. So that means this has to equal -1 or 0 or 1. No matter what number it is, you just set it equal to that number, but no matter what, you're gonna to solve for that x, we're going to divide by -1. So we get that, and then add 1. And that's what we did. We divided by -1 and added 1. So now we got 2, right? We got the 2. So if we were to place 2 into here, just evaluate the function at 2, we get 2 minus 1, which is 1, times -1 is -1. That's what we wanted. So now that's 3 to the -1, which is easy. And then as far as the arithmetic on the y, well, you just follow order of operations. That's why it's as is. You just multiply it by half and subtract 2. You just keep following the order of operations. So again, if it's -x minus 1 and you want this to be a 0 because you want to evaluate 3 to the 0 power, it's equal to 0. So you divide by -1 to get x minus 1 equals 0, and then you add 1 to get x equals 1, right? So we got 1. And if you plug in 1, 1 minus 1 is 0, 0 times negative 1 is 0, so it's 3 to the 0. That's what you want. That's easy. And then you do the order of operations, right? 3 to the 0 is 1, times a half minus 2, right? That's why we have this. That's why it's just as you, for the y, that's why it's just as you see it, because you're just finishing out evaluating the function. So if you have like this one, I mean, it's all the same. So equals 1. So we divide by negative 1. X minus 1 equals negative 1 plus 1 plus y. So x equals 0, right? So we got 0. And if you were to replace the x with 0, 0 minus 1 is negative 1 times a negative is 1. So 3 to the first, right? That's what was easy about 3 to the first is easy, right? It's 3. So 3 to the first is 3. And then you would multiply that by half and subtract 2. So again, all you have to know, you don't have to know that, but just know that the arithmetic is opposite and as is for the y. And when you have x, when you have a number for the x, you want to factor that out and then do this. Okay, well, that is all I have for now. I hope that helped. And I will talk to you on the next video. Thanks, guys. Bye.